Hello, everybody, and welcome to our webinar about Azure AI and how it empowers new possibilities for every organization. My name is Dmitry Shikhmanter, and I will be your host today. I'm here today with my colleagues from BlindSpot. BlindSpot is a member of Adastra Group, which are partner of Microsoft, and together we work with our common clients to empower and deliver them solutions. And BlindSpot, as a division of Adastra, is specialized on consulting and software development in services of machine learning optimization and artificial intelligence. I'm here with my colleagues, Christian and Martina. Christian has experience in software development and delivered a number of machine learning projects, including those on NLP and chatbots on Microsoft technology. So he will be talking today about that. And Martina was working with us almost 5 years, also delivering all sorts of machine learning projects across different industries. And in terms of Microsoft technologies, she worked on container loading optimization program, and also most relevant project about optimizing workforce in context of pandemic, so the teams have limited contacts. Let's look at our agenda for today and do some housekeeping first. So we kick off with a welcome introduction. Then we have a blog about Azure AI and what makes it so powerful, what tools it provides, and how can you use it within your organization. Then we will have a deep dive by Christian, who will tell us and guide through all the process of building, training, and deploying machine learning models at scale. Then we will have a break, and you should have received some instructions about how to set up your lab. We have written that we suggest that you try it 30 minutes before the start. However, we've received an update from our colleagues that the cloud instance should be up and running. So please just check it in advance so we can start. So, and the lab will be trained by Martina, and she will show you the Azure ML Learning Studio, so you will see how you can deliver, I think, 2 machine learning models within hour and a half. Then at 2:30 we will close and answer the questions. Talking about Q&A, please feel free to use Q&A button at the bottom or on top of your screen, depends on the device. We will record all the Q&As in the mean of presentation, and we'll try to address them either in the end of the section or in the end of the day, half day. Also, please note that we are recording this webinar, and I would like to keep your microphones on mute. As I said, in case of questions, you can use Q&A button and we will address the question afterwards. With that, let me get going on our first topic, empowering new possibilities for every organization. So Microsoft Azure has a tremendous adoption rate, and there are over 20,000 of paying customers last month, which is was a big figure. And it means that this technology is here, and it's here to stay, and this is already mature. So it means that if you are thinking about Microsoft Azure, you most probably won't be the early adopter. And the second part of the graph shows that we see that the structure is very interesting, that 85% of Fortune 100 companies has used Azure AI in last year. So we are not talking about small stuff, we are talking about companies as Volkswagen Group, for example. We are talking about big multinational banks. So they are already quite advanced in adopting both cloud and Azure AI. With this, I would like actually to start with a small poll among our participants to see what stage of cloud adoption you are in. So let me start the poll. So we can see a little bit about our audience, so we can adjust the talk accordingly. So I'm launching the poll, and we can start voting. So we have give 30 more seconds to finish the poll. Yeah, I'm ending the poll, and let me share results. So very interesting, actually, distribution of answers, as we see that there is nobody who is not interested in cloud, which is good, because why would one who is not interested to sign up for this webinar, sorry. And we also have nobody on the other extreme, so nobody has this production in enterprise-wide, so, which is expected because this journey takes some time, and this is inconsistent what we see with our clients. And we have actually smaller part is in production, and then the rest is equally distributed between on my radar, actively searching, and piloting first projects. So very interesting, and I think that our webinar today will actually address also this, first steps. What do you need to address? So I think this content will be extremely relevant for you. So thank you very much for sharing. And let's move on. So, so on the next slide, we will talk about, actually start with defining what is artificial intelligence, how we look at it, because I think it's important to set up this context, and it's also a lot of hype about it, and different people imagine different things. And the way how to look at it and how to reason it is that what we advise to our client is do not concentrate necessarily on the technologies, whether it's machine learning, or deep learning, neural networks. It's let's see what can deliver, what you can do with it. And in this set, we look at the artificial technologies as a set of technologies that enable automation, acceleration, and scalability of human perception and decision making. So it's here very important that human is the centroid of this distribution, no definition, sorry. Meaning that artificial intelligence is something that helps us to make things faster, to make more, and to automate certain tasks. For example, the most frequent use case is search on the internet. This is something that helps us to enable perception of the world, find information faster, and make a more informed decision. And here it is important actually to distinguish two things, general artificial intelligence and narrow artificial intelligence. So this general artificial intelligence that is subject of science fiction and the imagination of some robots that would supersede human. This is this general artificial intelligence that's supposed, to be fully autonomous. And there's also artificial narrow intelligence that is actually narrow in terms that it can do some particular tasks, but not, the general intelligence. So in this context, talking about if artificial intelligence will replace humans, it's very important to distinguish and realize that it's not about uh, it's not about replacing humans, but it's about helping them to do their tasks. And in this, I remember example in our client in automotive, and when we were talking about implementation some artificial intelligence projects, and he had like a very interesting thought. And despite of that, there was person that probably was 20 years in the industry and very conservative, and he said, we don't need to replace humans because we don't have these people. We need to help our colleagues to work smarter and faster because all that have experience and doing the work, they are already going to retirement, and the newcomers who have no experience are not so productive. So we need to enable them to give them the tools so they can have the same performance as if they were working there for 20 years. And now let's look at actually, so how close we are to get to general intelligence. And while all this recent development is actually about this narrow intelligence, this they said forecasting models, machine vision models is all in the field of this narrow artificial intelligence. So going back and see where it started and how close we are to some strong general is the same AI. So the idea of artificial intelligence is actually 60 years old, right? So it has been here for some time, and it started in 1963 with Marvin Minsky in MIT in the US, and he said, okay, give me funding and I will deliver, the first robots going around in 10 to 15 years. And as we as we know that it happened. And another milestone was in 1963, where actually researchers were thinking, okay, how to grasp it and what is actually we are trying to do and how to define what should be this benchmark to see if we have achieved or we have invented artificial intelligence or not. And they said, if the system is able to play chess, then it's intelligent system, because chess is not so straightforward, and presumably you need to be to play chess well, you need to be very intelligent in the result of decisions. So this could be a good benchmark. So they were working in this direction, and in 1997 there is a famous event when Deep Blue from IBM beats Garry Kasparov in chess. So apparently this benchmark was achieved, and if we have system that can play better than world champion in the chess, then we actually achieved what we wanted to do. And as we can suspect that still we don't have robots going around and fully autonomous. However, because the system was able to play chess very well and better than any human, but it still is not able to make a search on the internet. It's not able to make a conversation with me. It's not able to classify pictures. It's not able to predict fraud. So in this point of view, you cannot say this is generally intelligent. Later, in 2018, we see that we are a little bit closer to general intelligence in terms of technology which is able to deliver tasks more complex than playing chess, meaning self-driving cars is already complicated task which involves perception of what's going on the streets. They are different all the time. You cannot predict what's going on beforehand. You need to react. You need actually to drive the car, which is complex system itself. So it's not like chess where you have limited number of big but limited number of combinations that you need to calculate, or for example conversational robots like Alexa, because we have people with different voices asking different questions. You need to understand and somehow give them answers. but still the system which drives the car is not able, to make diagnosis of an X-ray pictures and cannot make the conversation, whereas the conversational robot cannot drive a car. So it's still, we are very advanced in this narrow intelligence, but we are still in the narrow intelligence fields, and we are not getting closer to general artificial intelligence, which will supersede humans, take our job, and rule the world. So having said that, going back to the Earth and having a clear distinguish what is artificial intelligence, what it is not, what it can deliver, and what we can expect for it. In order to start your AI project, I think it's important to realize three main things. And what are the prerequisites, so to say, of successful AI project? Well, so first, start with data, because this is just the nature of the beast. And here I've put have a right data to emphasize that it's not about the quantity, but it was about the quality. So for most tasks, there are tasks where you need a lot of data, but there is a big number of tasks which can be solved successfully with AI with a relatively small amount of data. But as I said, better data beats better algorithms. Then followed by this, also, we need to have a clear scope of the problem, because if we would have a general artificial intelligence, which we know is far away, it would solve everything without having defining what we expect. But the closer the scope, the better is defined the tasks, because as we said, it's artificial intelligence. It's not about jobs; it's about the tasks. The better the task is defined, the easier is to deliver solution. And last but not least, we need to have correct expectations. So we see two extremes. So there are skeptic people who, well, less and less of those, but there were like people who are skeptic and they just have no trust in the system. And on the other hand, there are very excited people who indeed say that, explicitly asking for us for an artificial neural network who would solve their problem that they don't, are not able even to define. So we need, and of course the truth is somewhere in the middle. The technology is mature, we've seen it, and 12,000 people use it every day on Azure, only on Azure, and have like big mature corporation in Fortune 100. So the technology is here, technology is mature, but you need to have a right expectation, because still it has its limit. Talking about the technology, there is something I would like to remind, which is called hype cycle, which is followed by every technology. And before deciding whether it would fit the purpose or you should use it in your problem that you're trying to solve, it's actually good to be aware of it and see in which phase of the hype cycle it is. So for example, everything starts with a trigger, and then it grows very high to the peak of inflated expectations, means when everybody is talking about. So it's not only maybe science article, but it's popular articles starts mentioning about some technology. So I would say that deep learning and artificial neural networks are maybe visible all over, and everybody is talking about them. So they're probably somewhere on the peak or after the peak of inflated expectations. Then, it's realized that every technology has its limits. So there is a sort of delusion where expectations basically show to be overestimated. Then it goes from slope of delusion and reach the plateau of productivity. Or if we go back, that when people saw that the machines who will play chess, they will solve everything, and then they realize that it was not completely true. However, some technologies used there are used today in applications that work reasonably well. So if we project this to the technologies available on Azure AI, we see that there is some research that already achieved human parity. So if you look from right to left, so object detection, this has already reasonable performance, so that it can be used and you can plug in your application. So if you need, if you have some problem and you have cameras installed in your store, in your branch, or in your match cashier problem, and you want to detect something which would be detected visually, that is done by human inspection or any kind of visual inspection, then you can already use some object detection technology, which is provided in terms of service on the Azure, so you can embed it in your application, and you don't have to be very competent in object detection technology. Same goes with natural language processing and conversational Q&A, which already close to human, or close or achieved human parity, because humans are also not perfect, and there is some questions they don't know answers to. So if you want to make a conversation with the client or any interaction in terms of conversation, you can successfully use technology enabled on Azure and only basically embed it in your flow, work on what is specific for your application, and delegate the AI on the Azure. Same goes for translation, speech recognition, and hardware that we will be talking about later. So this was some general introduction in terms of AI projects, and now we will project it to the stack and the technology and tools which offers Azure Machine Learning, and it can help you to deliver AI projects, and most importantly on scale. So we will go to the most important building blocks and what makes it so powerful, and what obstacles it can help you to go faster through. So first of all, its platform has tool for all skills. So we know that the data engineering, data science, and all this talent is scarce. And instead of hiring more and more people looking for these skilled people, it's better to give them right tools which are for their skills. So as you know, each organization has people who are hardcore coders, but also a lot of people who are more visual and they're used to some click, drag and drop interfaces. And Azure directly have it both, and this is what we'll look in a while. Then MLOps, as we see, is the biggest obstacle why companies don't have AI projects in production at scale. Right, very similar what we've seen with our questionnaire in the start. Right, so we know all this when we have team of data scientists working months on the projects, then they come up with they have the model, and then we ask them, okay, so how we can implement it, deliver it, how we can get it going, and then there is another project basically starts how to get it going, and all these bottlenecks. And if you want to operate this in scale, and if you want to have hundreds of machine learning projects running at scale, you cannot do it manually, implementing each and every project in your system, which would be a few months project per se. But luckily, Azure Machine Learning gives us the tool that you can basically, and we will see in the lab, that we can deploy a model in a few clicks. Openness is also very important because there are a lot of industry standard open source libraries available. So the data scientists can use Python, R, and all these libraries. So so there is a big community of it, and you can and you know there's no entry barriers. So if there is a person who is good in R, or he's good in Scala, he's good in Python, he's done all on TensorFlow, he can run very easily without any barriers and start working on the Azure from day one. And of course, last but not least, this is a trusted platform, because especially important when you need to propagate it through your responsible spine. That is a trusted platform both in terms of delivery, security, and audit trail, and all these compliance things. So let's look at these first three components into detail, and how Azure AI address this. So here is the example what the cross-functional team working on the project on the organization can look like. So on the one hand, on the left hand, you have people who are not using code, so they are using other more clicking tools. However, we want to empower them with the technology and allow them to make, the person responsible for inventory, we want to empower him with machine learning so he can predict inventory, he can look for anomalies in his data, he can perform some optimization, some scheduling. And for this, there is automated machine learning user interface, where basically it's a very intuitive drag and drop tool, where no coding required, and what is important, even not no machine learning knowledge is required. So all the person has to say that, okay, I want to predict this and this, so I want a prediction model, and here are the inputs, give me the outputs. And the algorithm will be fitted on the background. The best algorithm will be chosen automatically out of big set of available, and the result would be provided. So okay, so here is your forecast of your inventory, or here's the client segments, or stuff like that. So these analytical tools. Then we can move, to the next kind of spectrum, from clickers to coders. And there you have some analytical people or statisticians. Basically, myself, when I was studying, there was no AI machine learning subject. I was studying statistics. So I know about regression, I know different algorithms, but maybe I'm not so strong in Python. So I want to make some more advanced analytics. And there is Azure Learning Designer, where it allows you to assemble all the pipeline yourself, but in the visual interface with just pre-developed components, where you can make your own flow, and you say, okay, if I want to have random forest for this task, or okay, I want to make my own train test split, because I know there is some domain specific, so I don't want to make it random. I want to have some training set specific and my test set specific, because I know that it should be divided more by time. And also I'm also want to have optimization, more detail, and I'm aware that what I want to do, if I want to optimize false positive rate, true positive rate, how I want to weight models, which criteria, what feature engineer I need to take. All these can be done without any coding. However, some code can be done with some components. So the learning curve is very steep, and the people don't need any extra training, so they can deliver results very fast. And then we have on the full code solution, which is familiar notebooks, where one can run Jupyter, one can run R, one can run any basically code environment there data scientists or machine learning developers are used to. And so this makes actually a big impact, because as you see, all spectrum of your clickers and coders can suddenly have access to machine learning models, and they can incorporate in their work to make work faster, more optimized, and make smarter decisions and be fully autonomous. So this analyst doesn't need to go to data science, ask to develop the model. The model will be developed in Python, and the Python will be somehow developed. So this time to market or time to value is extremely fast, and this will make a difference. Next thing is actually, full tech stack and ecosystem, which is very important for seamless integration. Because frankly speaking, in the AI projects, machine learning is the model development actually is, it says 5 to 10% of the effort. All the rest, now we talk about production, not experiment, but production. All the rest is ecosystem around it. So here on the left picture shows basically entire value chain from raw data to insights and actionables. So you have either it's streaming data, or you want to monitor some events, or it's questions going to your chatbots, or it's a batch data. You have orders from the past, and when you want to predict inventory to the future, or you have some events and you want some payments and you want to predict frauds or stuff like that. So it's batch data. So it has to be somehow ingest. Either we are Azure Events Hub for streaming, or Azure Data Factory, which is basically ETL tool where you do your transformation, extraction, cleaning, and all necessary steps. Then you can store data in Azure Data Storage, which is also important, which is one of the enabler, because storage is getting cheaper and cheaper. And this is why these systems work better and better, because as we said a few slides ago, it all starts with data. And once we have data ingested, we have stored that, when we can run models on it. So here we can use Azure Machine Learning, and Azure Machine Learning itself gives a variety of tools, and starting from pre-developed components. So now if you want if you have pictures and you want to classify them, you can apply pre-developed vision capabilities, and just thanks to transfer learning, train your vision tool without going down all the way down to the rabbit hole and deploying some expert in machine vision. Same holds for speech, language, or search. You can empower, as we said, your data science with familiar tools. So if Jupyter, for example, is widely used in the community, so they can work in their environment, which are they used to. So no extra time need to spend to learn the new tool, which is Azure, because in essence they are working in their environment what they're used to. It can be Visual Studio, of course, as well. Azure Notebooks provide their own interface, and they can, most importantly, use their frameworks that we're used to, either PyTorch, TensorFlow, Scikit-learn, and they can benefit from the community, right? Because if you are stuck and you don't know how to do something in the Scikit-learn, it's very likely that you will find something on the internet. So it gives opens a lot of opportunities there. Development teams, and I would also like to comment on the hardware, right? Because this is also some obstacle which Azure helps to accelerate and go through. So for example, if you need to train extremely demanding model for the computational power, you can use elastically more CPUs. You can use, if you suddenly want to do the machine vision project, you can use GPUs, and most importantly, you can configure different hardware for different phases. So for example, for training model, it's much more hardware demanding. So you can just spin a lot of CPUs to run different experiments. And once your model is done, you can actually scale down because scoring is much less demanding than training, and use just a fraction of computational power. So it's truly elastic and enables you basically to scale if needed. And once the model is prepared and trained, ultimate goal is to serve it. So you can natively publish it to the Docker and manage through the Kubernetes service, and consume in your application, on your store in some operational databases, and visualize this data or use this in your application. Or you can report it directly to Power BI or do some ad hoc analysis in Azure Synapse. So it's very important that you can really deliver end-to-end within one system, so you don't spend this effort to integrate and say, okay, data is stored there, how can I access it, how can I publish it, how can I Dockerize it, how can I deploy it. So everything is here for you. And last but not least from this section is DevOps, which I talked about. And while we are familiar with DevOps in IT, now it's a very hot topic in machine learning is MLOps, because clearly it's not like you deliver product application, you ship it, and you forget about this. There's a life cycle going on, and you need to support this life cycle and keep your both data science, IT professionals in loop. And without automation, model reproducibility means that data science made something, and in production suddenly performs differently, or you cannot deploy it because it was done in R and you don't know how to put the R in your production systems. And the model validation, because once it's making some decisions, you need to make sure that it performs as expected. Deployment and also retraining, right? Because as I said, it's not like the advantage that you can retrain it and adopt it how the data changes and the clients changes and things. Is the advantage is constant retraining. But if you would have to do it manually, you can roll out one project, two projects, but if you don't want to do it at scale without automation is not possible. And luckily there is a ML ops capabilities on Azure that actually allows you to automate this cycle as following. So first you can create reusable pipelines in your Azure DevOps. So you can schedule retraining as you need based on some schedule, every week, every day, every month, or based on some triggers that data has changed. Okay, so in this table, I have new records, or something has changed, or new data arrived. So you train model. Next, once your model is trained, you need to somehow register it, because you want to have a version control. So you can deploy the better one or retire the old one. You can do champion challenger approach, right? So you can have a champion in place which is currently running, and you have new model which is trying to challenge it, and you can so you can actually automate this redeployment if the new challenger is better and will be a new champion, or the current champion will be still running. So this is number two. You automate your rollout, and you have all your versioning under the control. Then this is number three. So you need to create an audit trail, because suddenly if you see that it performs better or worse, you should know what's going on and which client was called by which model. And then our models are up and running. Either it's a web service, it's an analytical service, or maybe it's performing some calculations with IoT on some of the edge infrastructure. And you need, of course, to monitor it once it's in production. So you need to have confidence that it's doing what it's doing, because something can change, right? Data can change, and which is called data drift. So suddenly, the incoming data is a little bit different, and the performance is changing. So I think that there was a big issue, right, with the lockdown and COVID. Suddenly, the everything has changed, and the customers behave differently, or the processes are differently, and we need to spot it and retrain model very fast. So this is the monitoring capabilities, and then we have new model, and then we go around this cycle. And frankly speaking, done right, this can be all automatic. So you can put your champion challenger policy there. You can say what metric you want to monitor, what is the tolerated false positive rate, true positive rate, and predictions, how you can alert it. So, and thanks to automation, basically you can deliver one model, two model, and then instead of maintaining existing model, you can go develop more and more model and deliver more and more use cases in your organization. So talking about use cases, I thought it could be useful to see actually what we can deliver, right? So this is so these are some general applications which I think that can be delivered, and good candidates to be the first project, because they are I don't want to say easy, but fairly straightforward, and in some degree every client, every organization uses. So for example, predictive maintenance, it can be associated with manufacturing, but predictive maintenance basically it's monitoring, right? So it's monitoring if you're monitoring how your marketing campaigns are performing, it's monitoring how your loan portfolio is performing, it's monitoring how your logistics is going. So basically predict problems before they occur. It's quite a general task. Fraud detection, every company had internal audit team. So it can be fraud detection, it can be controlling, just when you want to catch something which is kind of anomaly. Intelligent recommendation, they're straightforward. Inventory management, demand forecasting, and sales forecasting, I actually take it as the same. It's kind of forecasting, so time series interpolation, and inventory management probably is a little bit different because it's more about optimization. And here I was actually wanted to mention that when we were talking about data, that optimization tasks are a little bit specific. So they are probably the only task which doesn't require a lot of data, because you don't need to train, but you have just input parameters. My container is this long, this wide, this deep, and I have boxes to put, right? This is all. You don't need historical data about how containers were loaded 10 years ago during like last year. You just need a set of rules and what you want to optimize and what your restrictions. So this is actually not so demanding for data, and it's a little bit different type, which we'll be talking about as well. So with this, I saw that it was very general. So let me maybe share with you. I have prepared 3 case studies, and we can look how it actually helped the organizations. So first one is it's from finance sector. It was portfolio monitoring, but it's actually equally transferable to any other domain which have a lot of data and you need to look for something. Basically, the common denominator is we have a lot of data and you're looking for the needle in the haystack. So the background here was as following. So there was a company who lends money, basically financial institution, major financial institution in CE, and first you lend money, and then and you score, of course, and you don't lend it to everybody, but situation changes, right? And they need to also, you need also to monitor if everything okay. And there are two things here. First one, if you want to find this 5% which are worth of attention, you don't know, they're not on the surface, right? So they're mixed somewhere over. So if you want to find the 5% of interesting ones, you have to go through 100%, right? And if you go only 50% of your portfolio, you will find only half of the what you're looking for, and the other half you will miss because it's somewhere, so because you don't make the monitoring. And they say, okay, that's probably not the best way to do it. And instead of going by one and checking okay, not okay, we need only to focus on not okay ones, right? But how to find it. And this is exactly the task which you can delegate for AI. So you have data, you have one prerequisite, you have basically the scope, right? So you are not saying, okay, give me find me clients which have problems. You can say, okay, so look at their there is a task, so look at their payments and look for some anomalies. Quite defined scope, and of course you need to make an expectation that and have some baseline, right? So people, it's important to set what would be success and actually to map the current status quo. So now, so you can say, like, look, now we do monitoring, we don't have time, we are doing 50% of, we can handle only 50% of our monitoring, and we find only half of defaults. But maybe so this is what we want to beat. And if we can, go only through 20% of portfolio, which, let's say 25% of portfolio, and which is only quarter of all portfolio, and find not only half defaults or 80% or 90% of defaults, it will be tangible increase, right? So we don't expect 100%, so we tolerate. Then we know that not every system makes mistakes. So, but we need to basically have this benchmark we want to beat. We want to find more defaults with less controls. And yeah, so that's what was actually done. We deployed the anomaly detection framework, and basically there are I would say three main advantages. First, it is continuous. It's not like, once in a year we would look for the financial statements of this client, because situation changed much more faster, and something can come between these audit intervals. But because it's automatic system, we can make these checks every day, every week, right? And if you do it every week, it's like 50 times a year. And if you do it once a year, it's only once a year, right? So it's already 50 times more than if we would do it as a human. Then what is important here, it's the really early warning. So you want to avoid surprises that basically, if you don't do this monitoring, then you would basically find out that something happened post facto. So you will go, okay, so the client will go to default, but why you do it? You do it to prevent it, right? So if you see some anomalies going on, that's something wrong, that you can call up the client and basically make some solution before it's too late, or somehow minimize potential loss, close the credit line, or ask for some collateral, some guarantees before it's too late. And actually, yes, instead of firefighting and trying to minimize loss, you can actually prevent this. There is another I will skip another cases because it's similar, and then I wanted to, in the last 5 minutes we have, I wanted, and then we have a few question Q&A. So I wanted to say about something about frauds, which I think is very interesting, and there are some important concepts. So maybe not think not about frauds, but you think that you want to detect something in your data. It can be frauds, it can be some opportunities. So how will you do it? You would define some problems, and do some rules, right? But these rules have to be, you need to know what you're looking for. Somebody has to define these rules, and you will find only what is defined in these rules. And this is a problem in fraud. So for example, there is a cell phone operator, they sell postpaid tariffs, and they, of course, if you sell postpaid, it means that you allow somebody to use the phone, and then at the end of the month, you send him a bill, and he may pay or may not pay, right? So say, okay, that we will check register of debtors, and if somebody is on the blacklist, it means that he didn't pay his debts in the past, we will not work with him. And then if they look at all who haven't paid to them, this is graph on the left, that most of them had no risk score. They looked at very clear in all these registers. But of course it's a bias, because maybe these people don't have any, they are not on the blacklist of the banks, because no bank has ever given them money because they were too risky and they could not see it. So it was their blind spot, and they somehow needed to differentiate, okay, so how can I manage the risk, and how can I quantify people who are they are not on the blacklist but they're still risky? So and it's a complicated task, and it's hard to find the rules that if he lives in this address, if he is very young, if he is very young, lives on this address, and he is actually ordering a lot of data, which is not typical, then probably there is a risk of misuse, right? So it's simply impossible to do it, but this is exactly what artificial intelligence can do. So they can, basically take all these people who are, in terms of these simple rules, the same, and do some micro segments based on these combinations of various different signals, and find some clusters of riskier and the riskier ones. And then when new customer comes, it looks in this with this model and puts him in the micro segment that is very important almost important to identify for humans. And here, so the amount of frauds were decreased by 30%, which actually delivered return on investment within 1 year. So this is maybe, in my opinion, very illustrative example, because we all have rules in our organization and we know that they are not perfect. The rules are hard-coded, they need to be managed somehow, they need to be updated, somebody has to analyze to make the data, make the rules itself, but this is perfectly something delegated to AI, and it can be data-driven, so the machine can learn these rules and actually update themselves automatically. And in the last few minutes, I would like to we have a question. So do you have an example of real application of Azure ML Designer for a customer? What kind of cases was it? Thank you. Here I would say that here it's very important for prototyping, rapid prototyping. So let me come back to the slide here. So Azure designing, we will look at a real application basically in the lab in the afternoon, so I encourage you to stay. And here it's very important because, to make a model in the code, it requires some time. But basically with this, if I have some hypothesis which I want to validate and say, okay, based on payments and attributes of the client, can I predict the frauds? I don't know. Good hypothesis, but I need to validate. So what I do like in the half day actually, I did it myself. a half day, actually, I can make such a design project and say, okay, I see some predictive power in the data. So the hypothesis is right. Okay, this model gives me some results, let's say 75% of precision. So it's already good enough. It's not good to be, final version, but it gives me hope, right? So maybe with the help of some special libraries, more sophisticated parameter tunings or more sophisticated algorithm, I can increase 75% to 95, then it can be good. So I can then go to this. But it's very important to understand if I need to go deeper, and the fact that I can do this basically extra exploration in half day, it's very powerful, right? And you can actually avoid you can validate all the hypotheses very fast and jumpstart from there. So it's for this is, in my opinion, is very powerful tool for this. And of course, if it can happen that only you can deliver some forecasting model that gives you desired performance only in Designer, then you can keep this second phase and then you can publish button and use it in the production. So I hope this answers the question. Many thanks for this. And we are now looking back to our agenda. We are now ready for deep dive to machine learning on Azure. And with this, I would like to pass to Christian.
Yeah, thank you, Dmitry. So hello, everybody. I hope that you hear me well. Let me just share my screen. And yeah, you should see it, right? Okay, so I hope that you have enjoyed first talk by Dmitry. Right now, I will also start by talking about Azure Machine Learning, but I will introduce it in much more technical detail and also with some code examples. Then I will move to the cognitive services, which is a set of pre-built solutions for specific machine learning use case that you can use inside your projects without like creating the custom model and working with like big data set, validating it, etc. So it's really good for getting on track really quickly. And then we will also look at bot framework, which is set of tools for creating chatbots and how it is well connected to cognitive services related around the NLP. Okay, so yeah, Azure Machine Learning is a set of tools created by Microsoft to help you develop machine learning models faster. And maybe you are asking, why should you use it instead of the tools that you already know? And the good news is that, as Dmitry has mentioned, it supports most of them. As we can see here, it has multiple plugins for popular IDE, such as Visual Studio Code. You can also work in Jupyter Notebooks, which is a really popular tool in data science world. It also supports two languages, Python and R, and provides SDK for them to manipulate with Azure Machine Learning. And it also supports for many popular frameworks such as scikit-learn, TensorFlow, or PyTorch that you are using on daily basis. So Azure Machine Learning builds upon that and provides you with a set of many really powerful and strong features that you can use. And now I would like to describe some architecture and basic terms that we will be using during this talk. So on the root level, there is workspace, which is basically a collection of your every machine learning assets that you can see on the that you can see here, such as environments, experiments, pipelines, datasets, models, and endpoints. So this is like your root directory where you keep all your project related data and stuff. This workspace can be also connected to additional Azure services such as compute targets, which is basically hardware that you use for running your job, or data stores, which are some abstractions around the storage where we are actually storing the data. And the good thing about this workspace is that you can add multiple users into one workspace and collaborate on one project, and it keeps everything at one place. And we'll be discussing these assets on the next slides. And here is just the picture so we can imagine what I'm talking about. You will also get your hands dirty with Martina after the lunch break. So you will actually click on, and you can click on everything you see here and try it in practice, how it actually works. Okay, so first thing, when you want to do actually something, you need some power, right? And compute target is abstraction in Azure Machine Learning for that. So it is basically machine or set of machines you use to run your training script or host your service. The good thing is that often when you are trying to run something locally, etc., you have to have custom environment, you have to pre-install some packages, etc. And the good thing about these computes is that actually Azure has prepared them for machine learning, and you can use them straight away. We can differentiate between training compute targets and deployment compute targets. Training are used typically for training jobs, such as working with your data, validating it, or training the models. And deployment are actually services that you use for prediction or inferencing, real-time inferencing. And it can be, for example, web service deployed to Azure Kubernetes, or it can be just a Docker image that is running somewhere on your virtual machine. And the really good thing about this is that you can scale very easily. So imagine that you are developing locally and you have some neural network that you want to train on a big set of data. It can usually take some time. And when you are developing locally, you don't want your computer to get busy, etc. Maybe you have also some servers at your company, but it's not that flexible to actually choose the right compute for the job as it is in the cloud. And Azure offers you many flexible options which you can use to scale according to your needs. For example, compute clusters, you can use them in your development environment when you are playing with the data, etc. And you can submit to that compute cluster multiple jobs, and it is scaling as you need. So if you need more power, it will scale automatically. If you need less power, it is scaled down. And this is really flexible way of working with these computes, since you can create them and then reuse them as you develop your machine learning projects. And on this slide, we can actually see the type of hardwares that you can choose. For the general purpose machine learning, we are using CPUs. Azure offers you also many variants, such as DFLM H series that you can pick from. They differ between each other with some set of parameters, such as how much RAM they have, etc. But for some specific kind of jobs, you would like, for example, GPUs. So you will create compute target with GPUs and use that. For example, when you are training neural networks. And what is also really convenient is that Azure supports FPGA, which is specialized hardware accelerated for deep learning, which can train and work with neural nets much faster. So yeah, compute targets provides like really good way of and flexible way of handling your hardware infrastructure. Okay, so once you have the hardware, you actually need some data, right, to do anything. So let me define these concepts first. The data set is in Azure Machine Learning, it is only reference to your data, which is stored in data store. And data store represents some storage abstraction, which can be, for example, underneath it, it can be actually MySQL or PostgreSQL or data lake, simply any abstraction that you would like to use. And you can manage your data sets and data stores in your workspace, and your workspace keeps track of them. So it knows like that you are passing your zipped file from one project to another. It is actually stored at one workspace and you can work with it. A good thing is that it is just a reference to something. You are not actually copying all those values to your workspace. So it's really easy to share between workspace and between multiple people. And you are also not paying for a storage. And we have two basic types of data sets. The first one is file. It can be, for example, images, or it is basically stream of data that you get from files. And you can also have tabular data set, which you are for sure familiar with. It is easily converted to Python pandas data frame. And it is basically a table which you know from relational databases. And the good thing about this is that Azure Machine Learning allows you to monitor and version those data sets. So once you create it, you can actually see when was it created, how it was created, and you can also monitor how it changes in time. And you can keep multiple versions of the data sets. And when someone is collaborating with you on that project and would like to experiment with something, he can actually see what data sets are present. He can see description of those data sets. He can also see the history of that. And he can also see where these data sets used for which experiments, which kind of runs, etc. So this is like a really great unified way of looking at the data. And I would like to mention one monitoring capability, which is detecting data drift. As Dmitry mentioned, it is the case where you have some data, you have trained your model with some data, but in production, when you're actually using that model for prediction, those data may change. For example, their units will change from centimeters to meters or something like that. And Azure, actually via those monitoring capabilities can like keep track of those like inconsistencies and help you with your monitoring. Another convenient thing is that it also provides a set of tools for labeling data, especially images. So if you have some data set and you need to label it, it is really easy to do it inside the Azure Machine Learning. And you have options to use either the SDK, which is the example of the SDKs here, or you can use Azure directly. You can create and manage data sets directly in the Azure portal. And here on the picture, we have just, so you get the idea how you can actually work inside the code with this, some code sample. Here we are creating data store and then uploading some data to it. And then we are reading from the data store, the same data that we actually written, but it doesn't matter. And we are creating some data set, which is tabular. And then we can register it inside the workspace and keep track of that. Okay, and now when you actually have machines, right, and data, the next logical step is to prepare your environment for executing something. And typically when you develop software locally, or you try to do some experiments locally, you need to install all the dependencies. You have to set up your environment properly, maybe download some data set, etc. And what is really convenient is that in Azure, you can actually define those environments. And as we see here on the examples, you can actually set which packages you would like that environment has installed, or environment variables, and you can use those for, and you can reuse that environment. So if you have a lot of people working in the same workspace and you have multiple types of environments, you can actually reuse them for certain jobs, for certain runs, really flexibly. So we can manage that and also reuse it as you go. And there is also option to build a Docker image out of it. So if you, for some use case, you would like to download this environment, and try everything locally, or send it, I don't know, to your colleagues, there is option to build a Docker image out of it. And yeah, so it's like a really convenient way which helps you develop this model faster and reuse those defined environments just by targeting them with name. So this is another thing that is being stored inside your workspace, and it helps with development. And then now that we have actually the hardware, we also have the data, and we have the environment where we can execute our code, we can start experimenting. In Azure Machine Learning, there is a concept of the experiment which consists of multiple runs. It is like directory for multiple runs. And basic run is just execution of some script. For example, here we can see that we are creating script run config. We are specifying which script we would like to run. We are giving it some compute, some power to actually process something. And then, yeah, we are submitting it to this particular experiment. If it doesn't exist in this step, it will be created. If it exists, the run will be appended to this experiment. And you can see inside the experiment like every possible detail about the run. And in typical machine learning workflow, you often do this locally. For example, you have Jupyter Notebook, and you're experimenting with your data. You're trying different stuff, different experiments. For example, you're trying to learn, you're trying to train your model for example, for I don't know, random forest or some custom model, and you are preparing data for that, and you are trying to visualize some useful statistics and get some insight. And many times you iterate over that. But you easily can lose the context, the whole context. How did you come to this place? What was all the data, all the graphs that you were looking at? And the convenient way about this in Azure Machine Learning is that all of that is being tracked. So on the next slide, I have example of run detail. And you can actually see here that run is part of the experiment. It have multiple properties such as which dataset it used, when was it created, etc. Here you have some concrete run, for example, run 35. And inside the run, you can see additional details. You can also see which models were created inside the run. You can see explanation of those models, if it's possible, to somehow interpret it. And you can also see metrics that were created, which is really, really convenient. You can then just look at it directly in your portal. You can share it with your colleagues, and you can see what is important, which is metrics, output logs, images, etc. And another very cool feature is that when you execute this run, this directory, which is specified here, is the Azure creates snapshot of that, and it is stored in run detail, as we can see here. So you can actually like repeat that experiment, repeat that run, even though you have lost your, I don't know, source codes, etc. So this is like a super nice way to have your things organized and to keep the history and track of history as you go and as you are experimenting with data. And it provides like a really lot of features, outputs. You can define your custom outputs, custom logs. You can run images inside one run. You can also run child runs. And so it's like a really powerful way of keeping your things organized and together at one place. And okay, and once your run has finished, you created model, for example, you can actually register it and save it into your workspace. And what models with the same names are versioned, which is nice, because when you're developing locally, sometimes your data changes, or you realize that you could try different features, etc. So it's a nice way to keep the track of the model. How was it created? Because you have the reference to the run, that this model was created by this run, and you can actually see all the details, all the data that was used, and you have everything in one place. And another thing is that you can very easily deploy these models using Azure Machine Learning Studio. It's just a couple of clicks where you define some configuration and deploy it, which can save you a lot of time, because typically you would need to create, I don't know, for example, Docker image, find some server where you would like to deploy it, etc. And the convenient way about this is the deployment can be simple as this. You will just define some compute power which you want. You will specify the environment that you would like to use for that server, also some entry script, and then you will just deploy it. So that's all you need. You need machine, you need some hardware, you need environment, and some script. That's how easy it is to actually deploy the model that was already registered. And the good thing about the environment is that you can actually use the same environment for development, for your training jobs, and same environment for production. You just reference it by name, and that's all it takes. And you can also choose between different compute targets when you're deploying. So if you need more power, or you are expecting bigger workload, you can choose from really multiple set of computes that Azure allows, and they can also be automatically scalable. So if your traffic is like time dependent, or I don't know, then you can actually pick this option, and it will automatically scale for you based on your needs. And the entry script that we specify here consists of two methods. The first one is init, where you actually load the model and create it using your popular framework. And the other one is run, which is like a callback for the endpoint that you are publishing. Where is your model running? So you get the request, HTTP request, you get the data, and then you can create the response for that. And also you can have real-time endpoints, which is like online web service, or you can have also batch endpoints, where you are submitting data once in a while. And for example, for recommendation system, you don't need to have those recommendations online every time user logs in. You will just run it every, I don't know, at midnight. And once the user logs into the app, he has all the recommendation he needs. And the bottom line is that it is very easy to deploy and keep track of your models, and also how did you create them using experiments and stuff like that, because you have everything at one place, well connected. Okay, so that was about the basic terms. And now I'll be talking about like set of features and tools that Azure Machine Learning provide. And first of them is the designer, which provides you with drag and drop workflow capabilities. And this is useful, as Dmitry mentioned, if you have a team full of people that differs with their levels. For example, some of them are better in coding, some of them are better in other stuff. But this is a cool way that using this graphical interface, you can actually allow to work multiple people on the same project, even with different set of skills. And here we actually see that when we are creating machine learning pipeline inside this designer, you have some set of predefined transformations, for example, and you can use them straight away without any need of coding. And it is also much more convenient to work with, since it's you can actually see the whole pipeline workflow. You have a set of predefined actions, and you are clear what you are doing with your data. And you will actually try this on the lab with Martina. Another feature is Jupyter Notebooks, which I already mentioned, that is being supported. And they are part of your workspace, as we can see here. You can create them and work on them as you are used to. But on top of that, Azure allows you to set, for example, compute, which you would like to use for this notebook. And you can also co-edit with your colleagues on the same notebook, even online. So it's like editing Microsoft Word document or Google Sheets, when you are actually working on the same thing together. But if you still prefer the standard Jupyter Notebook, you can easily open the Jupyter instance and Jupyter server and use the standard graphical interface for that. What is also cool is that inside this Jupyter Notebook, you have actually full support of code completion and showing the documentation, etc., as you are used to in IDE. So yeah. And the next thing here we have is automated machine learning, which was also briefly introduced. And the thing is that sometimes you start the new project and you have just the data, and you would like to get some sense of those data. And this tool allows you to get like really good sense of those data and create powerful machine learning models automatically for you, for like no extra cost. So you can use this, for example, at the beginning of the project to get the idea what your approach should be or what you should try. And Azure Machine Learning will do this for you automatically. He will try different models, and based on which models is performing well, he will like focus, he will edit his focus on certain subset of the models, and then he will try to tune their parameters. And once this is done, he will provide you with a set of metrics and these models, and you can actually see which features were important in this or this model. And you can somehow get you also get a lot of visualizations, and you can get the idea of, maybe you can get the idea really fast when you're starting project, how should you approach. So this is like super cool way of doing that. And it's as easy as this, as you see on the slide. You will just select data set. You will configure which kind of the job you would like to do. For example, classification. And then you're basically free to go, and it will all run for you. And also I would like to mention other tools which I've found really convenient for working with data. The first is Azure ML Interpret package, which is part of the SDK. And it is basically a package that allows you to somehow interpret machine learning models. Of course, it doesn't support or fully support like the full explanation of those models. For example, neural networks, which is really hard. But it can get you the idea what features in your data set are important. And this is really important when you are, for example, explaining your solution to the stakeholders, etc., that this would actually work and that you actually see some patterns in the data that make sense. So you can use this for interpreting those models. And it is, by the way, contained also inside this automated machine learning job automatically for you. And another tool is ONNX. It is a format of the model which can be run on the ONNX runtime. And when you are deploying the model, you have to make sure that your environment where you are deploying it is defined. It contains all the packages it needs, etc. For example, if you are using scikit-learn, you have to have installed that. You have to have installed correct version on your machine, etc., which can be cumbersome. But with ONNX, you actually convert all those models in those formats to one unified format. And you can then run this format using ONNX runtime anywhere. And very powerful feature about this ONNX runtime is that it is optimized for multiple types of hardware and also operating systems. So you get like sometimes even 2 times more performance while predicting, while inferencing when you are using this runtime instead of the raw model. So the bottom line is that this ONNX model format is really flexible since you can run it anywhere using the same runtime. And another cool feature is that ONNX runtime actually supports multiple types of hardware and is optimized for that. And here I have an example how like this whole architecture can actually look like in the production environment. So on the left side, imagine you have a developer who is developing and updating his application regularly. Then you can set up some pipelines, deployment pipelines that will download the newest version of some model and deploy it together with the application inside some Kubernetes cluster. And then you can also use that model, for example, for batch predictions with Spark. And you can store those predictions inside the database, for example, and then use it inside your app. And you can also have real-time predictions if the application needs it for some other use case. And you can track and collect all the data from the production and put it back inside your workspace. And your data scientists can then retrain, repolish the model based on how data is evolving and find, for example, some new clues and understand the whole problem better. And it's as easy as that since you have everything at one place. And all you need is actually like the model which is registered, and you can deploy it very easily using the whole Azure stack. So that was the part about machine learning. And now I will introduce you to cognitive services, which are a set of pre-built and smart solutions that you can use out of the box, which is super powerful about them. And Microsoft categorized them to these categories: decision, language, speech, vision, and web search. And in each of these categories, you have a set of services. And some of them you can use with little or no configuration, which is super nice when you are actually prototyping or starting using some application and you want to know whether this would work. But it is also well suited for environment because you basically deliver the application much faster since you do not have to worry about developing that machine learning model or smart service, since you can actually use it straight away. And also Microsoft is developing these services, so they are being improved they are still being improved, so you get the better result as you go. And on this, the examples of these services can be speech to text, text to speech, anomaly detection, For example, in vision, you can have face recognition and stuff like that. And I will be focusing on the language because it is closely connected to the chatbots that I'll be talking about on the next slides. So the first service we have here is called LUIS. It is a language understanding service, and I would like to explain it on the use case. So imagine that you have a chatbot, for example, in your home, like Alexa or Siri or I don't know, and you would like to tell him, for example, to turn the lights off. So when you tell him this message, the bot actually needs to convert it somehow so he understands it, for example, to text using speech-to-text service. And once he gets the sentence, he needs to find out what is the intent of that particular message. And the intent is actually to turn something off. But you also need one more thing, and that is what should I turn off? And that is called entity. So you need intent of the message and entities. And once you have that, the chatbot can actually have logic implemented for handling particular types of intents inside it. So if you will tell him turn the lights off, he will actually he will call this service. This service will return him the results that user wants to turn something off and he wants to turn the lights off. And then chatbot will take care of that. It is very easily configured. All basically you need is to provide set of examples. And so for example, if you have intent turn off, you will just provide set of examples, which are sentences, normal language sentences, such as turn the lights off or turn this off, please can you turn or can you shut down this or that. It's basically just a set of examples. And LUIS will learn machine learning model for all your intents based on those. And it will take care of that complex logic of natural language processing. So you will just provide a set of couple examples. And the good thing is that Microsoft actually offers you a set of pre-built domains that can be reused automatically. So you wouldn't need to specify these sentences manually. You would just click on the button that you would like to infer these intents, and it will get set up for you automatically. It is also providing a set of monitoring capabilities with rich number of graphs and visualizations, and it is available as the web service via REST endpoint. And on the next slide, I have example how it can look like in how does it look like in the LUIS portal. So on the left side, we can see that we have something called app assets, which are intents, entities, and pre-built domains that I was talking about. And here we see detail of particular intent, which is called home automation turn off. And at the bottom of the screen, you can actually see the set of examples for this intent. And you also have inside the portal dashboard and some tools to manage actually. And once you have provided all the examples, you will just click on the train and it will get trained for you. So this is how you specify intent inside the LUIS. But now you also need entities, and LUIS offers you many pre-built entities such as date or numbers or stuff like that. And you can automatically detect those. But you can also predefine your custom entities, such as device name or device type or location. And then LUIS will be able to automatically detect this type of entity inside the message. So that is really, really powerful when you are creating chatbot solutions to have this type of model. And it is all done for you. You just need to specify the examples, specify the intents you want, and entities, and you can use it straight away. So, and yeah, here we see the example. In normal application, it would be JSON, but just for simplicity and for the sake of demonstration, I have shown that this could be, for example, the query: turn the lights and radio off. The intents that will be detected from Louis will be home automation turn off with score 98%. You can also filter the intents based on their confidence. So if Louis detected some intents but with low confidence, you can actually reply in chatbot that sorry, I don't understand this message. Can you specify somehow differently? Or you will give users some set of the options to click on, for example, some buttons, and you can make sure that you understand the button, because there is like some action that some callback inside your code. And here we also have entities. We have two entities, lights and radio. And we know that types of those entities is home automation device. And once the chatbot gets this message, he actually knows what to do, because this is given by the intent, and it knows what entities it is targeted for. And in this case, it is lights and radio. And another like common use case is that in chatbots, you want to respond to some questions. Because there can be like many set of questions, like thousands, and you want to have the capability of answering them. And for that, Microsoft created Q&A Maker. And yeah, it is very useful for answering questions such as frequently asked questions. You are training it with pairs of questions and answers, which can be and answers can be also formatted using, for example, Markdown. You can also very easily allow this service to have chit chat capabilities, which is basically small talk. So your chatbot would be able to answer questions such as "How are you today? What is your name?" etc. It also supports for multi-turn conversations. So you are asking question and then asking something such as sub-question, and you are showing these answers as you go in the conversation. And your responses can be also you can give some text to them, and you can use those texts to pick the right answer for your for the question. So for example, if you have a user in London and users in Paris, and the user is asking what is the good restaurant near me, you can have predefined answers for London and predefined answers for Paris. And you can distinguish between them based on this tag and give the user dynamically the proper answer. And it is also available on the endpoint, on the REST endpoint. And it also provides you with a set of really cool monitoring features and visualizations and graphs. And once you have these two tools, you can combine them to create like really strong chatbot solutions. And basically out of the box, all you need is to give it some examples. Here we can actually see how does it look like in the Q&A Maker portal. On the left side, we have a question. You can also add many alternative phrasing, which helps Q&A to pick the right answer for the question. And on the right side, we actually have the one answer. And how does it infer this is it takes the user input, it finds like the best matching question, and then it will pick the answer for that. And very powerful feature that Q&A Maker allows is to gather all this information, Q&A pairs, from your data. So for example, you can give them properly formatted Microsoft Word documents, and it will actually automatically create this whole knowledge base for you. And then you have the solution to answering user questions out of the box. Of course, you will have to somehow tune it, because it doesn't, it can't like be 100% correct. And you will also need to add some alternative phrasing to those questions, so your model is more flexible and more consistent. But it is like very good way to start creating this model, and very powerful tool for actually creating your whole knowledge base out of your already predefined documents. And other features that are used commonly with these services is dispatcher. You may have multiple LUI services. It should be focused on one particular use case, and multiple Q&A models. And dispatcher allows you to automatically connect them together. And then you are calling dispatcher, and dispatcher is taking care of everything, and is also taking care of picking the best model for you. Because you typically want to pick the model with the best score for the request. And this is done automatically by the dispatcher, which is available as a command line tool. And you're basically creating LUIS application, which will take care of that for you. And another cool feature is active learning, which suggests fixes in knowledge bases based on the active feedback. And it can also do this automatically without any feedback at all. So if you have the application, for example, LUIS, but you specify the very similar set of examples to multiple different intents, what it can do is it can show you that these intents are very close to each other. You should give me more examples. How should I differentiate between them? Or it can also give you suggestions, like concrete suggestions at this sentence, at this example, to this intent, so I can be better at predicting it. And the same applies for Q&A. So this is like very powerful way of improving your models, as it is reacting to your audience, because it is basically adapting to your audience. And yeah, it's basically adapting to your audience and improving as the time goes. So those were the cognitive services, LUIS and Q&A, and they are most commonly used inside the Microsoft Bot, together with Microsoft Bot framework. And you may be asking, what is it? So it is a set of multiple tools that you can use for creating chatbot solutions. And on this slide, I have examples of those tools. You can, one major, and first let me start by like talking what's the problem here, and why would you need some tools in the first place. Imagine that you are developing chatbot and you try to connect it to multiple channels such as Facebook, Slack, etc. Since your audience can be anywhere. And each of those platforms has their own APIs. And if you would do it manually for all those APIs, it would be a really mess, since those APIs are being changed constantly. And yeah, you would need to create a solution for very big list of providers if you want to support your clients on all platforms. And Microsoft Bot Framework allows you to connect to these channels and convert automatically requests and responses for you. So you can focus on implementing the logic of the chatbot instead of handling all the additional complexity of connecting it to some particular platform. Microsoft Bot Framework also allows you to use some set of pre-built skills, which is something like a microservice in a domain of developing web services. You can imagine it really as a microservice, which is handling some concrete use case, such as managing your calendar. And that skill typically will have some LUI service connected to it, and maybe also some Q&A service connected to it. But that LUI service will only handle the stuff about calendars. And this is a good way how you can modularize your complex chatbot application to multiple skills and then connect those skills using dispatcher, etc. And as I mentioned, the bot framework allows you to use a set of pre-built skills, so which is really nice. Then you can also have Composer, bot framework SDK, and emulator, which bot Composer, I will show it on the next slide. It is basically a graphical designer that helps you creating the conversations, chatbot conversation, dialogues, etc. Bot framework SDK is a framework that you can use for creating chatbots using code. If you prefer full flexibility of code, this is the right solution for you. And if you would like to test the chatbot and have some channel, because imagine how would you test the chatbot? You can of course send HTTP request, but this is like not like a really good way to test them. So you need some graphical interface for writing the messages as you would on Facebook or any other platform that this chatbot is connected to. And this is provided to you by the emulator. And this, when you're creating the bot, it can be easily deployed to Azure. They have native support for it since it's their solution. And you also get many other features which are really nice to work with. Here we have like the whole architecture, how it can actually look like in how actually like what solution can look like. On the left side, you have the input from the user, which can be tapping on the buttons, since messages can contain buttons, or some cards, which is basically set of images, text, and buttons. Or user can also speak to your chatbot or type some messages. And this input can be from multiple channels, each using their format, each using their APIs, etc. And all of that is gathered inside your Azure bot service, and it is provided to your bot as one unified object. And then you can use services such as Q&A or LUIS to actually know what was the request about. And then you have your skills, which is set of microservices of chatbots. And you can have particular skill, for example, for mail or for calendar or for automotive. And each of those chatbots can take advantages of Q&A, language understanding service, or maybe even speech to text or text to speech solutions. For example, if you have something like a home assistant as Alexa, you would also need text to speech. And here we have the example of how Composer can look like. We can actually see that here user is creating a dialogue. You can define the steps, which is basically like a pipeline, but you can also add many conditionals and dynamic flows here. So for example, if something is true, for example, the user has answered with some particular set of answers with some particular set of intents, do this instead of that. You can also branch or loop, as we see here. So until user enters valid birthday, don't continue. And you can define many complex scenarios here very easily. And this Composer is also really flexible, since you are basically using some dynamic variables, as we can see here. You are not using like concrete text. So it offers you a set of a lot of capabilities. And you can also use HTTP requests, for example. when the conversation gets to some particular point. For example, imagine you have dialogue about the booking of flight. And when you gather all the data from the user, where he would like to go, for what price, etc., you can actually send HTTP request to your backend service, which is keeping track of that. And that backend service can, for example, make a reservation, make a booking for the user. So this is really powerful. And if you still prefer code first way of doing things, you can still do it inside your favorite IDE using Bot Framework SDK. And the languages that are being supported are C#, TypeScript, Python. Python is being supported since 2020, I think, and the Java is in preview. But I think like the best language I think for that would be is TypeScript or maybe C#, since they were supported from the beginning. They have many samples of how to do things, and they are like really well suited for this job. The main concepts in these SDKs are turn context, state, and dialogues. Turn context is object that is being created for you, which contains all the information you need to process the message that came from the user. For example, user ID, what channel it was, what was the message, etc. And it also provides you with a set of operations that you can use to respond to that message. So you can, for example, send, using this context, activity that you are typing, and it will show in user chat that you are typing. Then you will do some calculations, and then you will send him actual, for example, image, or you will send him a message with the buttons, or you will send him some prompt that you are asking for his name. And you can add validations to that prompt, that until user enters correct name, which is a string without numbers, for example, he can't continue, and it will be looped inside that prompt. Another really important thing in chatbots is that you typically need to store the state and state of the conversation, because you will the request will come to your service, to your chatbot, but you need to have the context and the state. What were you talking about with user? And this framework offers you a set of really powerful tools to manage the state. And so it's really easy to define multiple types of states and reuse them as you go. And the last thing is dialogues, which is basically, as I was showing you here, it is set of one particular functionality, such as greetings or welcoming the user or booking a flight. It consists of multiple steps that can be branched or looped, etc. So it's basically like a function inside your chatbot. And it also offers many convenient classes for working with dialogues. You can also have multiple types of responses. It can be text, it can be buttons, it can be cards that have pictures in them, text in them, and also buttons. But this is limited by the platform you are talking to, since not every platform supports the same type of responses. But what Microsoft Framework does is it automatically converts to supported format. So for example, if you have somewhere cards, images, and text, and particular platform doesn't support it, but Framework will create image from that and it will send it to the user. So it's like really flexible way of using all available features for almost any platform that Bot Framework supports. And as I already mentioned, it is really well suited to use with LUIS and Q&A, because you often need to know the intent of the message or entities and react based on that. Or you can have, you can let your chatbot answer some questions. And yeah, this is that support for multiple channels and automatic request response conversion I have already talked about. So yeah, that's it. Just to sum up, we've been talking about Azure Machine Learning, which provides us with a convenient way how to create, manage, and deploy machine learning models upon the tools that you are already using on your data science project. Then I was talking about some cognitive services. In our case, it was particularly Luis and Q&A, which you can connect to create powerful NLP solutions. And lastly, I've been talking about how you can connect those services to create powerful chatbots using bot framework. So yeah, thank you for the attention. And yeah, I'll be happy to answer your questions now.
Thank you, Christian, for this. I will just bring up the agenda. So I think it was a lot of information by now. So again, thank you very much for listening. At this point, we don't have any Q&As. So we are perfectly on time. It means that we are here now starting for the break, and we come back at 1 p.m. By this time, we will jump in hands-on. So Martina will walk you through Azure Machine Learning Studio, where you can prototype your first ML models in a drag and drop interface. So you should have received the link where you will find the pre-deployed cloud instances, where you go and just fill in your name, email, and activation code was distributed to you there. And we also prepared some manuals, just so you know. And then we will start at 1, and we will be looking forward seeing you there. If you have any questions in the meantime, please feel free to drop it in the chat. I will do, or Q&A. I will be controlling this, or in the email which you received in your sign up. So I see that both Q&A and chat is empty. So yeah, so we will see you at 1 p.m. Thank you. Hello, Martina.
Hello, Mitya. Yes, I can hear you. I think everything works well.
So I guess everything works okay. I have tried to log in as a participant with other email. It works well for me. And had a very good instruction.
Perfect.
So good afternoon, everybody, and welcome back. We see that the number of participants is still growing, so we will allow, let's say, 5 minutes to everybody to come back, and we will allow everybody to get themselves comfortable and set up your environment if you haven't done it already. I've tried it and everything went smooth for me according to the link and activation code that was distributed. So I hope the same for everybody else. In the meantime, I see the question in Q&A, which says, is there any issues while dealing with other than English languages? So I assume this is the chatbot related question. And I would like to answer that we did realize projects in Czech Republic, in Czech language as well. So Slavic language is not an issue. However, of course, it's not so straightforward. So we did some work to investigate which encodings to use and how to use it. And it took us some time to figure out, but ultimately the solution performed very well. It was a message classification problem in Czech language, and we achieved 95 plus accuracy. So other than other language is not an issue. However, some work needs to be done to figure it out and make optimal configuration.
So I think the number of participants is consistent for quite some time already, so maybe we can start. So hello everyone, good afternoon. I hope you're all ready to start some practice after you've been listening to the to my colleagues talking about interesting stuff for 2 hours. And my name is Martina Tija, and I'm gonna walk you through the Microsoft Azure Learning Studio, and we are gonna practice what some part of what we were talking about in the previous part, and we're gonna learn some simple prediction model using the designer in the Azure Machine Learning Studio. So I'm gonna share my screen with you, and I hope everyone can now see this homepage of the Microsoft Azure Machine Learning Studio. If not, just let me know, please. So this is the homepage of the platform that we are going to use. On the left-hand side, we can see the menu from where we can access all possible things that we might need for our work. We can create a new notebooks, automated machine learning, or a designer. We can observe all the assets, like data sets, experiments, pipelines, endpoints that we created, and we can manage compute data stores or data labeling. What we are going to do today is we will design a simple machine learning pipeline using this drag and drop tool by Azure Machine Learning. And yeah, what this model is going to do is it will predict the price of the cars based on some parameters that are known for those cars. So to implement this pipeline, we simply need to click Designer and use this easy-to-use pre-built module option. Yeah, and we will get to this canvas where in the center, there is the place to build this pipeline using the drag and drop models from the left-hand side. What we need to implement some prediction model is for sure some data set, some data transformations, maybe feature selections, machine learning algorithms, then some model training and evaluation things. And if we want to make it a bit advanced and we need some custom code, then we might need this either Python language or R language modules that are available here. And on the right-hand side, we see some setting for this pipeline. So to run a pipeline, we will for sure need some compute target. And I would just like to ask you at the very beginning to create one, because it might take some time and we don't want to be waiting for it once we need it. So here in the settings, we need to select the compute target. So click select compute target. And either we have an existing one, which I suppose you don't have yet.
Yeah. I'm sorry.
Yeah.
In the chat, there is a question. And,
Oh, sorry.
Can you please maybe go one step back before logging to this ML? So basically, where you after you have removed the desktop, right?
Mm-hmm.
With this lab, this switch basically from this lab on this cloud studio, how to actually get in this.
Oh, okay. Okay, so everyone was, I hope, received an email. Just check all my messages, and
Yeah, I'll send it. I'll send the link to chat. One sec. Give me some time.
So from here, everyone has received this email, and we just need to click the launch blob. And yeah, but in my case, it's running already.
Try to go to the link I've sent to in the chat.
From this part, yeah, in the chat. Okay. Okay. Yep.
Let me take the screen.
Okay. Yeah.
So I assume that the question is, so by default, you are here, right? Some remote desktop, some remote desktop, and here you have a tab, the environment, where you have basically username and password. This is all you need to get going. Basically, what you do, you open the new window, right? So I do it in the computer tab, and then I go to Azure. Okay, to the instructions. So with this I go to. So I'm here. I go to portalazure.com. Go to portalazure.com, where I put the credentials from there. Right. So I go back in my remote desktop, cloud on demands. All right. So I copy my username here. Next. And I copy my password from here. I go here. Here. And enter. So basically, I'm here. And Martina, where should I go now?
I will send the link.
Services.
Yeah, this is the link in the chat. ml.azure.com.
Oh, sorry, ml.azure.com. ml.azure.com. And the workspace is already loading. Azure Labs 1. Basically, only one options here. I go get started, and it loads my workspace. And so here you are already where Martina was showing. So I hope it helped, and everybody is on the same now. I'll pass back to Martina, and let me check the Q&A. Okay, so Václav is asking how can I open ML Studio. So I hope it is clear. So fine. Okay. So if there is somebody else who needs guidance how to get into ML Studio, how to use the credentials which is generated by this temporary instance.
So are we all ready?
Okay, yes, so
I don't see a message by Václav. Maybe it was private message.
So no more. I don't see any reaction. So please get going, and I will keep an eye on the chat.
Okay, perfect. I'm sorry I didn't see the message in the chat because I was on this screen. So we are back here, and I will just repeat what we need to do. So we click Designer, use this easy to use pre-built modules. We get to this canvas, and at the very beginning, we need to instantiate the compute target. So please, all of us select compute target, and we create a new target. Here we will have a predefined compute target, which will be enough for our case. So we give it a name. Let's call it lab target, and we save it. And I already had one before, but you all should have one lab target here, which has the status creating. So it's not yet ready, but it will be ready soon, and we will be able to use it for our pipeline. So what we will do is that we will, as I already said before, we will try to train a model which predicts the price for cars. This dataset is available here as a sample dataset provided by Microsoft Azure. In the normal everyday life, we will for sure work with our own datasets, not only those by Microsoft. If you need to use your own dataset, you just click here from datasets. I will just show you, don't do this now, please. But here I click the dataset. I get to a window where I can create new dataset from wherever you want. So for instance, from a local file, I will give it a name, specify that it's a tabular data or what it is. And here there is basically a step-by-step manual how to import the dataset. And once we are done with this, we will see the dataset in this part in the datasets. But let's not do it now because we have this one ready, and we will work with this automobile price data raw dataset. So we drag it and drop it here to our canvas. Now on the right-hand side, we see some detail information about this module, about this item that we dropped here, about the dataset, but there is basically nothing interesting here. But what we can do with the dataset is that if we click it and then right-click it, we can visualize the dataset output. And yeah, now we see the whole table that has 205 rows and 26 columns. Yeah, the columns represent the parameters of the car, like drive wheels, body style, and so on. And each row represents one car. If we click at any column, we can see some statistics about the column here, the frequencies, and yeah, the basic things that can be interesting for us. What we see as the first thing here is that there is a lot of number values in this normalized losses column, which might have a negative impact on the performance of our model. So we see that we need to do some pre-processing on the data before the training data. And in case of this column, it seems that it's pretty messy, and we will just drop it. And it actually is not the only part of this table that has not a number of values. For instance, also this price column, which is what we want to predict, has some not a number data. So what we will need to do with this data is we simply drop the rows. So this will be our pre-processing. Let's get started. So we have the data set, and we first need to do some data transformation. So let's open this data transformation panel, and we search for we need something to drop the column. So select columns in dataset. We drag it and drop it under here. Now we need to connect those two parts of the canvas. If we move the mouse here, we can see that from this square, from this part, we can get the dataset output, and here we need the dataset. So let's connect it this way. There is not that many options. And now we need to specify which columns to select. So we click this square rectangle, and here we have the option edit column. The selected columns will be based on some rules. And what rules? So we want to include all columns, and we want to exclude. So we add this option, we have include here, and we exclude column based on column names. And yeah, what was the name of the column that had a lot of not numeric values? It was the normalized losses. So this way, we will keep all the columns except for the one that has the name column normalized losses. And we save it. And let's add some comment to this column, to this, I don't know how they call it, canvas part. And we exclude the normalized losses column. And now we can see like directly in this rectangle what this particular operation or data transformation is doing. So now we remember that we still wanted to get rid of the rows which had the not a number values, especially those that were in the price column. So we want to clean the data. There is the clean missing data option. And yeah, what we want to do is we want to include in this cleaning process, we want to include all columns because we basically want to clean all the rows that have any non-numerical values. So we include all the columns. And we want to drop the rows. So remove entire rows, which has the minimum missing value ratio 0 and maximum missing value ratio 1. So we drop all the rows that have some missing values. Yeah, and let's just again give it some description. So we clean all rows with some missing values. Yeah, and again, we have to connect these two rectangles to continuously create a pipeline. So now we have the data ready for training. It's clean. And what we need to do to train a data so that we can test it later, we need to split it into the training and the test set. So it's again some data transformation, and it's called split data. So let's just drag and drop it under this bracket, and we want to split it so that the training set contains 70% of the values, and the test set contains the rest. Now, we need to again connect it to the rectangles above. We have two options here. So the first part from this clean missing data bracket returns the cleaned data set, and the second contains the cleaning transformation. So what do? We need the data, and we just connect it to this input port of the split data transformation. And from the left part, we get the trained data set, which is the 70% of the data. And from the right part, we get the rest, the test data set. So now we want to use the training data set to train some model. So let's open this model training, and we select this train model. And this train model consumes the data set, which will be the training data set, and it consumes the untrained model. So let's select the model. In the first part of this tutorial, we will implement a pretty simple data prediction model. So from this machine learning algorithms, we select the linear regression. And I can't see it. Oh, here, linear regression. And it will be, yeah, the input to this train model. Train model square. Everyone is following me now? I just checked the chat that there is no one lost. I hope I'm not too quick or too slow. And yes, how do we train the model? So to train the model, we need to know what is the label column. What do we want to predict? So we have to click it, go to this details, and edit the column. And we select the column whose name is we wanted to predict the price. So let's save it. Now, when we train the model, we want to score it on this test data set. So we have to select this model scoring and evaluation. And from here, we take the score model. And the score model has the input, the trained model. So we have to take the trained model. Here in the previous one, it was the untrained model, and the result is the trained model, which is the input to the score model. And here we need to connect it with the test data set. And the last step is that we want some statistic on how we performed with this training. So we need to evaluate the model. So let's just drag and drop the evaluation and connect it with what should we connect it? Let's just move the mouse here, and we see that we have to connect it to the scored data set, which is exactly what we have here above. So now we have the definition of the pipeline for a pretty simple regression model or prediction model. And what we need to do now is we want to train it. For this, we needed to instantiate the compute. But as this training will take some time, I wanted to show you some more advanced stuff that we can do with this drag and drop function. And meanwhile, we are working on the advanced part. This model will be training. But we will basically we want to basically reuse this thing because we will do a pretty similar things. So once we have this pipeline ready, we want to clone it. So let's go here on the right hand side. There is just 3 dots, and we can select the clone. Or maybe first, if we clone it. No, I cannot clone it to the second, to another window. Okay, so let's just submit this pipeline and we will run it. We will run the experiment. So we need to specify some information about this. I hope everyone has already the compute ready. And we will create a new experiment. We will give it a name, so lab regression experiment. And here we have to have the compute target that we selected before. And let's submit it. So here we can see that the pipeline is now running. And yeah, so it will take some time to run, and we can see it here in the experiment part. Let's just open it in the new window. And yeah, I already ran some experiments in the morning, and now I can see this one that is currently in progress. And yeah. And hopefully now it's still running and I succeeded to clone it and I can continue my work on it. Yes, so what I did is that the experiment that we submitted before, and which was like here, it was obvious that it was running. I just clicked the 3 dots and clicked clone. And now I have the same environment with the same pipeline where I can do some small changes and see the performance of the pipeline with these changes. So everyone is here having the pipeline that we can, again, like we see this button submit, and in the experiments page we can see our experiment running. So no message in the chat. I hope everyone is following. Okay, so what we want to do now is I want to show you that there is a possibility to actually run 2 models at once and compare them in one canvas. So we already were using this linear regression before, so let's just make a difference and delete this linear regression. And instead of this, we will use a different machine learning algorithm. So let's select this boosted decision tree regression. It needs to be regression because we have a continuous data set. The prices are continuous. And yeah, we keep those parameters that are predefined here. And yeah, we fit this to the train model rectangle. So the only thing that we have changed, we reused the same data set with the same cleaning procedure, but we changed it to algorithm that is used for training. And we want to train 2 models at once. So let's just take this model training and we use another train model. Square again, we will train it on the price. But what we can see now is I dropped it here and I want to specify the edit column. And now I cannot see anything. Well, the reason is that this module doesn't know what it operates on, of course. So we first need to connect it with the training data that we will, that we will feed in. And now we can select the column from, no, so we still need to select the machine learning algorithm. So the second machine learning algorithm will be this decision forest regression. We drag and drop it here, connect it with this train model, and now hopefully we will be able to specify the label that we want to predict, and this is going to be price again. So let's save it. And we will again score the algorithm. When you're scoring an evaluation, and we select this score model. The input to this part will be again the train model. I don't know if you noticed already, but whenever you click on this port, it automatically highlights the port that you should connect it with. Like, it gives you a hint what will be the input to this port from the data you already have here. And we want to score it against this test part of the input data that we get from the right port of this split data rectangle. And that's it. And yeah, we already saw, maybe we noticed at the beginning that this evaluate model has two parts, and both of them are actually data sets. So this is the original data set, and this is the data set to compare it with. So let's just connect this. And yeah, that's it. We should be ready to train two more models, which will be the boosted decision tree regression and the decision forest regression. And thanks to this module, we will be able to compare which of them has a better performance and which of them we will want to use for some future predictions that we need to, or evaluations that we need to do. So I will just give you some time if you need to catch up with something, but I hope everyone has this pipeline ready. And I will just have to have a look at our experiment, which is still running. And yeah, I will just open the experiment and I can see how far we got during this time. So the only completed part is this linear regression module, which basically didn't do anything. And now we are still selecting the columns in the data set. So I think this will take some time. And we can submit this one as well and create new experiment. And the name is lab comparison regression. And I will again use this compute that I've created before. Now both the experiments are running. Okay, let's see the chat. Chat is empty. So I think I can just give you some time to finish if you are not yet finished. And meanwhile, I will just show you some things that you can, that can be useful here in the designer. So I will open a new canvas. And oops. So I will open a new canvas, hopefully. Yes, and so what I find pretty useful, especially when you don't know much about this drag and drop functionality at the beginning, and is that whenever you, let's say, you want to use some data transformation, but you don't know how actually it works. So there is, when you drag and drop it and click it, here in the detail on the right-hand side, you can see down here the module information, which will guide you directly to the Microsoft documentation of this module, and you can see the detailed information how this can be used, with like descriptions of pretty much everything. And yeah, the same holds for all the modules that can be imported here. You can already see it now on the left-hand side that this this documentation is pretty well organized and pretty detailed. So this part can be useful. Yeah, and what I forgot at the beginning was that not only we want to train a model, but we also want to deploy the model so that it can be run from anywhere else and it can be available to your colleagues or other people. And for this, we will need another compute instance. So what we need to do now is we go down here, and in this compute section, so I just clicked this compute section, and we can create a new inference cluster. I already have one Kubernetes service here, but you should all be able to create a new cluster here. We need the Kubernetes service. We specify the region where we are right now. And yeah, and here we can specify some particular Kubernetes cluster that we need, or we just click on next, and it will provide us with some like standard cluster for general purpose, which will be enough in our case. We give it some name, so lab cluster, And here we need to select the number of nodes, which when multiplied by number of cores must give us at least 12. So we need 3 nodes if we have this cluster with 4 cores. And we click create. Yeah, I will not do it because my environment is already has one cluster, but you also should do it in case you want to deploy our trained model once it's actually trained, because this one will be used. Yeah. So it will be running for some time, and let's see how is our linear regression doing. So in my case, it's still training. But what we already can do here is once it is completed, some of the parts, we can display what is the results. We can visualize it. So the same like we visualized the data before, we can now visualize the data after this transformation. So we just select it, then we right-click it, and see the result data set. And yeah, after this transformation, there should be no this normalized something column. And yeah, it was in the second position, so we can see that it actually did what it was supposed to do. It has also 25 columns, and here we had 26, I hope. Yeah. And we had 205 rows, so let's see how many rows are left after we clean the data set. So from 205 rows, we are left with 193 rows. And those are already the clean data that we will train our prediction model on. So the data is ready. We can see this completed mark, and the training didn't start it yet. What about the second part? Oh, okay, so this one was faster, and now we are running this train on this more advanced one rather than the previous one. Okay, never mind. So yeah, once this all is completed, as I already said, we can publish and deploy this model so that someone else can just send the data and receive the prediction. And for this, I already have my experiment prepared. And yeah, what I had to do for this already computed pipeline, which was exactly this pipeline, this linear regression, is that I created I transformed it so that it can be deployed. We will do this together once the computation is done, but I can just show you the result now. So it transformed in a way, and we deployed it. We deployed it to using this Kubernetes service, and the result is this. Sorry, the result, we have the endpoint where the service is running. So once we create everything, we deploy it, we get this endpoint. We can click we can click on the details of the endpoint, and we can see the definition of the REST endpoint. We can check the Swagger definition for what the input data should look like, which I will just prettify somehow. Swagger viewer. Yeah, and what the endpoint consumes is not surprising for us. It consumes a JSON with a form, like in this format, where for each web service input, we specify the parameters of this car. So each web service input represents one car with all the parameters. It also contains the price, but this price, of course, is not taken into account when predicting. And when we send it to the endpoint, we will get the result, which is the prediction. So we can either test it directly here by selecting this test, and you fill in the values for all the parameters and click test. And we, as an output, receive this prediction, or we receive the parameters again, and the last parameter is the prediction. So we can see that the actual price was this number, and the predicted price was this number, which is pretty close. Or we can not only test it here, but of course we can test it using Postman. I already have the request here. So we are sending a post request on this address, which is specified here. In the headers, in the authorization, we are authorizing it by a bearer token, which we can see here in this consume part. We are using this key. So I just copied this primary key and pasted it here as the token. And in the body, I am sending the parameters for the car. I only am sending one here, but when I send the request, I receive the very same result like I did received in this test environment directly in this Azure Machine Learning Studio here in the test. So let's just check that it gives us the same price, and yeah, this is exactly the same number like in here. Yeah, so this is just to show you that a train pipeline can be directly deployed using this environment, and you can use it from wherever you want. And let's see, so this pipeline is almost ready. This one is also being computed soon. Okay, let's check the chat if someone has anything. Seems good. Training is finished, and we just wait for this car to be computed, and we can see. We can try to deploy it so that we get each of us we get the endpoint to check the results. Okay, so I think this pipeline will be ready first because we already finished with scoring the model. So let's just wait for this evaluate. And then we can compare the two models. We have some message that it's not refreshing automatically for some reason, so maybe we're done already. Yep, the run is completed. Cool, so now we can deploy our trained model. Pipeline is ready, but I cannot. I cannot see it here, so we have to clone it again to get into this environment. No, not this one. Experiment. And we want the regression experiment. And this way I got into a different environment than I wanted because I cannot see the option to publish the model. To create an inference pipeline, because with this one I will not be able to do it as I already have this. I have the two trained models here, so I cannot publish it when there are like two models. I only need one, so we will do it in this one. But let's see the evaluation. So when I visualize this evaluation, I can see some numbers. Initially, the first row belongs to the experiment on the left-hand side, and the second row it corresponds to just an experiment on the right-hand side. But this is not quite obvious from this table. So what I just want to do is I want to add one column which tells me which row corresponds to which experiment. For this, I will use this Python language, execute Python language script option. And yeah, I connect it with this evaluated result. And what do I want to do with it? there is 3 parts for this execute Python script. The first one is a data frame, the second one is a data frame, and the third one doesn't work here, it's disabled. So we have one data frame, so let's just connect it with the first part, and let's define the Python script. So there is already some predefined code with comments that can walk us through the process of creating the Python code. The important thing is that there must be this function which name is Azure ML main, and it has 2 input parameters, data frame 1 and data frame 2. We only provided it with the data frame 1 input, which is the result of our evaluate method, and we want to add a column to this data frame. So we want to define new columns, and it will be a pandas data frame which has columns, and the column name will be model, and it has data which will be the name of the models. So the first one is the decision tree regression, and the second one was the decision forest regression, or what we use, let's say decision forest regression, and the result will be the concatenation of the 2 data frames. So the first one will be the new columns, and the second one will be the data frame 1, and we want to concatenate it with axis 1, and the output of this function is this result. Yeah, so I hope it's correct. Let's save it. And yeah, now we have everything computed here. And the only thing that is missing is this evaluate Python script. We want to submit this again, and yeah, it took around 15 minutes before, but the thing is that nothing else has changed. So there is some cached result for this pipeline, and yeah, it should be pretty quick. No, and we can, yeah, use the same experiment and submit it, and let's see how quickly we get the data computed. So yeah, you can see that this part is already completed, and the only thing, which was pretty quick, and the only thing missing is this last Python script, which has not started yet, but it shouldn't be much of an effort. Now it's running. So you can see that there is a lot of things you can do using only this drag and drop functionality without the necessity of writing a single line of code. But whenever you need to use some more complex functions or like some custom functions, it's pretty simple to just reuse a code that you previously developed or tested somewhere in notebooks or in your SDK. Oops. So there is some bug in our script. Um, so we are inserting columns in. Oh yeah, it should be just a simple typo, which is date instead of data. Okay. Okay, and my keyboard stopped working right now, so I cannot unfortunately rewrite it. But yeah, I hope that you guys haven't done this. Sorry?
Maybe comma after result, return result comma.
The problem is that I named it date instead of data.
Okay.
As you can see, but the problem is that my keyboard is not working for some reason. I know what I will do. I will just copy A from somewhere. Copy. And now it works. Perfect. I don't really know what's wrong with my keyboard the last few days. So yeah, let's just submit it again. And hope there is not any more typo. Yeah, I was editing the code already. This is Daniel is writing me, but yeah, the problem was just the keyboard, so I'm sorry for that. So we are done. Let's check the results. Oops, no, not this. Okay, and we now have the table from where it is clear which model has a better performance. So basically in all aspects, the first, the decision tree regression has lower mean absolute error, root mean square error. Yeah. So the first model performed, I would say, better. Not in all aspects. But yeah, depending on what you're using it for and what are your necessities, you can select one of the models based on this evaluation. Yeah, and what I wanted to do as the last step, but I'm pretty sure we won't manage it today because it again takes some time, is that I wanted to publish the model, to deploy the model, sorry, so that you can, you can have the endpoint, which you can call either from this testing environment or this, or from Postman and test it yourself. For this, as I already said, we only can have one model in this pipeline. So I will choose that we keep the boosted decision tree regression. So I will just delete the whole right-hand side. You can, of course, train a new experiment or like do it any way you want, but this will be the quickest way. Yeah, evaluate model, you want to keep it.
In the meantime, maybe I can comment the question how to explain the trained model. And it's actually out of scope of this lab. However, there are plenty of ways how to explain it, meaning basically you can generate so-called feature importance to see what features have the biggest weight on the final prediction. You can also do some sort of sensitivities, right, where you can see, you can basically hold all parameters constant and, for example, change the number of kilometers of the car and see how it influences the predicted value. So, you know, more than explanation is basically a separate topic, and you can actually use some components outside in Azure, but outside of this, you know, studio that can help you visualize all the necessary features and statistics and variables that explain how the model is deciding, basically. Sorry that for interference.
No, it's not any problem because we're still waiting for the evaluation. Yes, and now basically when we drop to the right-hand side, the only module that has changed is this evaluate model, which is why it's taking some time, whereas the previous models were done immediately. So we are now done, and we can proceed to create the inference pipeline, which is the first step we need to do to create the endpoint, the desired endpoint. And we will select this real-time inference pipeline. So let's click it, and we will see that this the Canvas pipeline structure will change so that it can be used as a web service. Yeah, so this is the result that we have. And now we will click this submit. And we'll create a new experiment, which will basically again run this web service pipeline. And this is why it's again gonna take some time. So experiment, we will submit it. Yeah, and yeah, we're pretty much done. The only thing that we will have to do is once this run is finished, we will deploy it. Clicking this deploy button, then we will select our Kubernetes cluster that we previously have defined under this compute here. Yeah, it should already be running, I think, for each of you. If you try to instantiate this inference cluster, and yeah, then we will get to the point that I showed you previously. After the deployment is finished, we will see this. We can check this endpoint, and there should be the endpoint for where our web service is running, in which we can easily access the way that I showed you. So yeah, this can be a little after hands-on self-task for you if you are interested into trying this. And I think this is all for me, because this will take the rest of the time that we have for this lump, so we won't be able to probably deploy it anyways without exceeding the time that we got for this hands-on. Yeah, so I hope that everyone learned something from this tutorial, and that I was not speaking too loud, showing stuff, speaking too quickly, showing stuff too quickly, and yeah, you were able to follow, and at the same time you didn't get bored. So if you have any questions, don't hesitate to ask, and me or Mitya will kindly reply.